There are moments in history when a single object refuses to stay within the boundaries we have drawn for the past. It does not announce itself loudly. It does not arrive with spectacle. Instead, it sits quietly, almost unremarkable, until someone looks closely enough to notice the contradiction. The world of ancient technology is one we believe we understand. We assign it limits, primitive tools, gradual innovation, slow advancement. And yet, every so often, something emerges that seems to belong to a different timeline entirely. The Baghdad Battery is one such object. What if the ancient world was capable of harnessing electricity, long before the age of wires, generators, and scientific theory? What if knowledge existed, not as a continuous progression, but as isolated fragments, discovered and then lost? The idea unsettles the neat structure of technological history, because electricity, as we understand it, is not supposed to exist in antiquity. Not in the first centuries of the Common Era. Not in a clay jar buried beneath the soil of Mesopotamia. And this is where the contradiction begins. To understand the weight of this anomaly, one must first return to the world in which it was found. Ancient Mesopotamia, often described as the cradle of civilization, was a landscape of innovation. Empires rose and fell along the fertile banks of the Tigris and Euphrates rivers. By the time of the Parthian Empire, which controlled the region roughly between 247 BCE and 224 CE, this was a world already steeped in engineering, trade, and craftsmanship. Metalworking was advanced. Glassmaking was refined. Medicine, astronomy, and mathematics had long histories. Yet despite these achievements, there are boundaries that historians have traditionally held firm. The systematic use of electricity is believed to have begun much later in the 18th century, with figures like Alessandro Volta and Benjamin Franklin. Ancient civilizations, while sophisticated, are not thought to have understood or utilized electrical energy in any practical sense. But here is the unsettling part. In the early 20th century, an artifact emerged that seemed to challenge this assumption. It was not grand. It was not adorned with gold or inscriptions. It was, in fact, quite simple, a small clay jar no more than a few inches tall. And yet, within its modest structure lay a design that would provoke decades of debate. The discovery is most commonly attributed to Wilhelm Koenig, a German archaeologist and director of the National Museum of Iraq, who examined the object in 1938. The artifact had reportedly been unearthed earlier, during excavations near Kujut Rabu, just outside modern-day Baghdad. The site itself was associated with Parthian settlements, placing the object firmly within the 1st centuries BCE or CE. The jar, as Koenig observed, contained a copper cylinder, formed by rolling a sheet of copper into a tube. Inside this cylinder was an iron rod, suspended in the center and isolated from the copper by asphalt or bitumen plugs. The top of the jar was sealed with the same material, securing the internal components in place. At first glance, it appeared to be a simple container. But upon closer inspection, its structure suggested something else entirely. A clay vessel, a copper cylinder, an iron rod, insulated components, a sealed design. These are not random elements. These are the essential components of a galvanic cell. This is not myth. This is stone. Koenig proposed that the artifact could have functioned as a primitive battery, capable of generating a small electric current when filled with an acidic liquid, such as vinegar or grape juice. The hypothesis was both intriguing and controversial. If true, it would imply that ancient people in Mesopotamia had not only encountered electrochemical reactions, but had intentionally constructed devices to harness them. History does not break easily, but here it bends. As researchers began to examine the object more closely, experiments were conducted to test the theory. Replicas of the so-called Baghdad Battery were created using similar materials, clay jars, copper cylinders, iron rods. When filled with acidic solutions, these replicas were indeed able to produce a measurable voltage, typically around 1 volt. The implications were profound. A single unit might produce only a small amount of electricity, but multiple units connected together could potentially generate a more significant current. This raised an immediate question. If the ancient builders understood this principle, what might they have used it for? And this is where the debate deepens. The physical facts themselves are not disputed. The artifact exists. Its components are real. Its structure is consistent with a basic electrochemical cell. The dating, while not exact, places it within a plausible historical context in the Parthian or early Sasanian period. But interpretation is another matter entirely. The mainstream academic position remains cautious. Many historians and archaeologists argue that there is no direct evidence that the object was used as a battery. No wires have been found. No associated devices or systems that would require electricity have been uncovered in the same context. Without such supporting evidence, the function of the jar remains speculative. Some scholars suggest that the object may have been used for entirely different purposes. One possibility is that it served as a storage container for scrolls or sacred texts, with the metal components playing a structural or symbolic role. Another interpretation proposes that it was part of a ritual object, perhaps used in religious or ceremonial contexts. But here is the unsettling part. These explanations, while plausible, do not fully account for the specific arrangement of materials. The use of both copper and iron, separated and insulated within a sealed container, is not an obvious choice for storage or decoration. It is, however, precisely the configuration required for generating an electric potential. Alternative interpretations have attempted to bridge this gap without straying into speculation. One of the more widely discussed theories is that the device may have been used for electroplating. Electroplating involves using an electric current to deposit a thin layer of metal onto another surface. In ancient times, gold and silver plating were highly valued techniques, allowing artisans to create objects with the appearance of solid precious metal at a lower cost. Experiments have demonstrated that small currents, such as those produced by simple galvanic cells, can be sufficient for basic electroplating processes. If the Baghdad Battery were used in this way, it would represent a remarkable, if isolated, technological achievement. Yet even this interpretation faces challenges. There is limited archaeological evidence of electroplated objects from the region and period in question. Most known examples of ancient metal plating appear to have been achieved through mechanical or chemical means, rather than electrical processes. And so, the mystery persists. What makes the Baghdad Battery so compelling is not just what it might represent, but what it reveals about the limits of our historical understanding. It forces a confrontation with uncertainty. It asks whether knowledge can emerge, disappear, and leave behind only fragments, objects without context, designs without explanation. There are precedents for this kind of discontinuity. Ancient Greek texts describe devices and mechanisms that were not fully understood again for centuries. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, revealed a level of mechanical sophistication that seemed out of place in its time. It was not until modern imaging techniques were applied that its true complexity began to emerge. The Baghdad Battery belongs to this category of artifacts, objects that resist easy classification, that sit at the edges of what we believe to be possible. And yet, caution remains essential. The temptation to project modern understanding onto ancient objects is strong. It is easy to see familiar patterns and assume familiar purposes. But history demands restraint. It requires that evidence lead interpretation, not the other way around. This is why the debate continues, even decades after the artifact first came to wider attention. New analyses, new perspectives, and new discoveries may one day provide clarity, or they may deepen the mystery further, because not all questions in history have answers. Sometimes what remains is the object itself, silent, unresolved, waiting, a small clay jar, buried for centuries, carrying within it a design that feels both simple and impossibly advanced. It does not declare its purpose. It does not confirm its use. It exists, and in doing so, it challenges. What if it was a battery? What if it was not? Between these possibilities lies a space of uncertainty that cannot be easily closed. And within that space, the past becomes something less stable, less predictable, more complex than we often allow. History does not always move in straight lines. Sometimes it loops, sometimes it fractures, and sometimes it leaves behind objects that seem to belong to a story we have not yet fully understood. The Baghdad Battery remains one of those objects. Not because it proves anything definitively, but because it refuses to be dismissed. And in that refusal, it quietly asks a question that still echoes across time. How much of the ancient world have we truly understood? And how much have we simply assumed?